Okay, so this video goes over a worksheet for cyclic and aromatic hydrocarbons. If you would like to try this worksheet before you take a look at this, you can head to my website and scroll down. There's an organic section, and if you scroll down just a little further, you'll find anything highlighted in yellow is a worksheet. So the worksheet is right here, and then you can take a look, try it before you go for the answers. This is my website. It is linked in the description, so you can always check it out there. And if you do find this helpful, please subscribe. So the first question that we're going to go over is just being able to draw a cyclopentane. So if you have something that's cyclic, you'll always see that word cyclo beforehand, and you just want to make sure that you are connecting your hydrocarbons. So for this one, pentane means 5, so we're just drawing 5. I did a line diagram, but you could do a structural diagram, you can do a condensed diagram, but usually with cyclic and aromatic, you'll see those line diagrams. The second one, name a 6-carbon cyclic hydrocarbon with 1 double bond. So if I wanted to kind of take a look at what one of these could look like, if I had 6 carbons in my ring and I place a double bond anywhere there, then this would be called cyclohexene. So cyclohexene, E-N-E for that double bond. You don't have to say where the double bond is, because no matter where you're numbering, we always give the double bond between carbons number 1 and 2. And it doesn't matter if you're left to right or right to left, it's always going to be between 1 and 2. The next one, cyclohexane. So again, 6 carbons in your main chain, but this time you have a methyl group attached. You can put it wherever you want, and that will be known as carbon 1 once you attach it. If there was anything else, we'd add it on. Again, we know to connect all of our carbons because the cyclo in the word. The next one, name the aromatic compound consisting of benzene ring with a CH3 substitute. So with that one, if you were even just to draw this quickly, right, if you have a benzene ring, that's not the best drawing of it, but close enough, and you have a CH3 group, a methyl group on there, it's again assumed to be on carbon 1. So you don't have to say where it is. You would just write this one out, methyl, because that's what CH3 is, and then benzene. And then this one would be aromatic because you do have the benzene ring. Drawing benzene, you just have to draw 6 carbons, and you either will see it with those alternating double bonds, or you can put it that circle in the middle, and that's what it would represent, those alternating double bonds. Now drawing 1,2-dimethyl cyclobutane. So cyclo connected, bute means 4, so like a box. And then it doesn't matter where you start, as long as you put 2 methyl groups that are beside each other, because that would be now carbon 1 and 2. And you can go clockwise or counterclockwise as long as it's between on carbon 1 and 2. Number 7, name a cyclic hydrocarbon with 7 carbons and no double bonds. This one you can just write out. If it's 7 carbons and it's cyclic, you can write cycloheptane. We would have the ending A-N-E because we don't have any double bonds. Number 8, draw ethyl benzene. Benzene ring, we have 6 carbons with those alternating double bonds. Put that ethyl group wherever you want, just as long as you show that you have 2 carbons in that chain, and now that ethyl group would be on carbon 1. Number 9, draw the carbon compound, a benzene ring with 2 methyl groups in the position 1 and 3. So benzene ring, we will draw that out and put that in the middle. If it's positions 1 and 3, again, you can start wherever you want. Now, as soon as you place 1, that is carbon 1. If I go counterclockwise, then my number 3 would be the third one over. Draw cyclohexene. If it's hexene, that would be 6 carbons in your main chain. Cyclo, it's connected. E-N-E, we need to put a double bond somewhere. So pick wherever you want. That is now carbons 1 and 2. Name a 6-carbon aromatic hydrocarbon. If it's aromatic, it must have benzene, and benzene already has 6 carbons, so we can just write benzene. Number 12, draw propyl cyclopentane. Pentane means 5. Cyclo means connected, and a propyl group, again, put it wherever you want, but has to have 3 carbons. Now again, I'm doing all line diagrams, but you can do whatever type of diagram you are comfortable with. Name the compound a benzene ring with a Br substituent. So with this one, if it's Br on there, you would just say bromo to represent the Br group, and then benzene. That's all we have to do. And because it's just one, the bromo group would be assumed to be on carbon 1. If we had anything else going on, we'd have to number it. Draw 1,4 dimethylbenzene. So we draw our benzene ring. Again, start wherever you like. If I'm going to go clockwise or counterclockwise, it won't matter, just having to start. If that's 1, 2, 3, 4, that would be my other methyl group. Number 15, draw and name a cyclic hydrocarbon containing 8 carbons and 1 triple bond. So if it's cyclic, we want those all connected. If it's 8, gets a little messy with the drawing. So let me see if I can do that here. 1, 2, 3, 4, 5, 6, 7. So let's go this way. Not the best drawing, but hopefully we get the idea. So I have 8 carbons. Oops, that 1, 2, 3, 4, 5, 6, 7, 8. And then it's just my lines are messy, but if I wanted to put a triple bond, again, pick wherever you want, make it clear that you have a triple bond there. And then we are going to name this. So if it's 8 carbons and it's connected, we have cycloalkanes and then YNE for that triple bond. Again, it's assumed to be between carbon 1 and 2, so we don't have to say where it is. And then this very last one, knowing the difference between cyclic and aromatic. So even though aromatic carbons are connected, if it's aromatic, you must have the benzene compound somewhere on it. So we're looking for that 6 carbon chain with those ring with those alternating double bonds. To be cyclic, you just have to be connected. So you could be cyclic, but not aromatic. Just to be aromatic, you must see benzene. So I hope you found this helpful. If you did, please, please, please subscribe. And if you're looking for some more work and activities or lessons, please check out my website. Thanks for watching.